I can look for parabola. Start with negative b over 2a. I can look for parabola. Start with negative b over 2a. This is only for standard form. Vertex form gives you the vertex already. Word to your mother.
All right, well, welcome back, Algebra 1 students. And here we go with some more graphing of these quadratic functions. And that video is kind of nice to see again, just some of the parabolas in real life, like the water going across in a parabola form. And at the very end said, vertex form gives you the vertex already. You don't have to go through all the stuff that we did in the last lesson. We don't have to find negative b over 2a to get the x coordinate. We don't have to plug it back in to find the y coordinate in order to get the vertex, because vertex form, which is what we see here, graphing f of x equals a, parentheses, x minus h, parentheses squared, plus k, that's our vertex form, and it's going to give us the vertex automatically. And we'll see how that works out here when we get to graphing these. All right, so our cartoon today, we have another Far Side cartoon. Two guys sitting there, wheelchairs, bandaged up from head to toe. You're kidding! I was struck twice by lightning too. Oh boy, these guys have some bad luck, I suppose, as they would say. Here comes an asteroid careening down and gonna squash the two of them, I suppose. All right, here we get into first of all our core concept on 262. Before we get into graphing these vertex forms, we're going to talk about even and odd functions. So this is kind of really not even related so much to the vertex form. They just kind of throw this in here in this lesson for even and odd functions. And so basically we can determine whether a function is even or odd, or it could be neither one. So it doesn't have to be one or the other, it could even be neither. So it might ask you a question eventually someday, is this function even or odd? And here's how you figure out how. So an even function, remember it does tell you y equals f of x, that we should know now, by the way, is f of x is just our function notation for a y. So a function's even if you plug in negative x for x in the function and it comes out to be exactly the same. It doesn't change anything about the function at all. That's going to be even. But a function is odd if you do the same thing by plugging in negative x, and what you get out is the opposite of the function. Every term in the function is its opposite sign as the original. Now, if it doesn't do that, either one of those, then it's going to be neither. So let's take a look at our extra practice to start off with 1 through 4. Just determine whether the function is even, odd, or neither. So in this one, it actually doesn't give us all quadratics. In fact, it gives us our first one as a linear function, then everything else here is a quadratic. But I put over here on the side, and you should write this down maybe in the margin, or if you have some space on a previous page, what you're basically doing for even and odd functions, and you can maybe probably write it down even underneath this core concept here, is to plug in negative x for x. And when you do that, if it doesn't change anything, everything stays the same, then it's even. If it changes all the terms to their opposites, then it's odd. And I must hit there, changes all the terms. So if it changes all the terms to their opposite, then it's odd. If it changes some of the terms but not all terms, then it's neither. All right, let's go ahead and see how that works out here. I'm going to go ahead and do number 2 and 3, and I'll give you a chance to try 2 and 4. Sorry, 2 and 4 I'll do, and I'll give you a chance to try 1 and 3. And there we go. All right, so for number 2, we're going to plug in the negative x for the x. So essentially, this is what I'm going to end up doing. So in the negatives, we'll start with negative 4. And instead of x, I'm going to put in negative x squared. And then let's see what we would get out here. So a negative x times itself, negative times negative, would be positive, and we're going to get negative 4 now times x squared. So as you can see, nothing changed. It's exactly the same as the original. So if it doesn't change anything, then we would say that it's even. So that's an even function. Plugging in negative x doesn't change anything of that function. Number 4, let's try 4 here. Let me move this over here. Number 4, we're going to put in negative x into 2 places in this function. So it's going to start off at negative 3 and then negative x squared plus 2 times negative x plus 1. So for this term, negative times negative will be positive x squared, so that's going to be negative 3x squared. This term is going to become negative 2x, and this still has the 1. So on this one, the first term didn't change, but the second term did change. That was different, and the third term didn't change. So if it changes some of the terms, but not all the terms, then it's neither. It changed some of the terms, it changed the middle one, but it didn't change all the terms. So in this case, it's neither an even or odd. We just say neither for that one. All right, so do the same thing on 1 and 3 and see if it's going to be even, odd, or neither. Go ahead and pause the video and do that, and then play it to check your answers. All right, so you're checking your answers for 1 and 3. If I try it for number 1, if I plug in 5 times negative x, what's that going to give us? It's going to give us a negative 5x. So on this one, it changed every term. So it changed all of the terms. There's only one term, but it did change all of them to its opposite. So we would say this one is an odd function. Okay, so it was 5x, now it's negative 5x. Since there's only one term, it changed all the terms. Number 3, we have the 1/2 times negative x squared. And again, what is equal? Negative x times itself is a positive x, so it's going to be positive 1/2 x squared. So it doesn't change anything at all. Still exactly the same as the original. So this one would be even. So you should have had odd for number 1 and even for number 2. If you didn't get that, then go ahead and fix that on your paper. All right, let's move on to 5 through 8. Now 5 through 8, here we're going to now get into graphing in vertex form. So before we get to there, we need to figure out just the important points or important things of the graph, which is the vertex and the axis of symmetry. We did the same thing when we were doing 8-3, except then to find the vertex we had to, do negative b over 2a for x, and then plug that x number in that we got to find the y for the vertex. And the axis of symmetry is always going to be the x-coordinate of the vertex. This time, vertex form has an A, H, and K. Those 3 are the important numbers. This is going to be a number, that's going to be a number, and that's going to be a number. The vertex is the H and the K. Okay, so vertex is H and K. A right here, this one is going to be, we'll talk about A when we get to graphing. But right now, just to find the vertex, it's H and K. Now notice it says x minus H, so it really is going to be the opposite. When you take it from inside here to putting it in here, it really is the opposite of what you think. K is exactly the same, but this one's the opposite. So you might want to write down a little note here. This one, I'll put a little OPP for opposite. This one is same. So it almost looks like the opposite for H, but the same for K. All right, let's go ahead and try a couple here. I'll do again the even ones over on the side and give you the chance to do 5 and 7. So for finding the vertex, so we can see right here that there is no, so we got our A number, this is our H number right here. So that's our H. There is no K, so K would actually be 0. There's no K in the back. So we can think, okay, the H is 8, but I talked about it being the opposite. So if it says x plus 8, then your H really is going to be a negative 8. Negative 8. And the K in this one is the 0. So K will equal 0 in this one. So for your vertex point, it's going to be negative 8, comma 0. Your axis of symmetry is always going to start off with x equals, and then it's just the x coordinate of the vertex, which would be whatever the H is. So in this case, it is negative 8. So it's down here, it's just going to be x equals a negative 8. Number 8, here we have, again, our A number would be a negative 1. So this is our A right here. A number would be negative 4. And that one, A would be negative 1 here. This is our H, and this is our K. So in this case, H is going to equal negative 1, because it's the opposite of what you think. It comes out as the opposite, because it's got to be an x minus whatever that is. So if H is negative 1, x minus negative 1 will simplify to x plus 1. The K on this one is exactly what it is. It is a negative 5. So your ordered pair there should be negative 1 comma negative 5 for the vertex. And then your axis of symmetry is going to be x equals the negative 1. All right, so that's simple. All right, so go ahead and pause the video. Do the same thing for 5 and 7 and just identify the vertex and axis of symmetry of each one of those. And then play it to check your answers. All right, so you're checking your answer for number 5. So your H would be positive 2, your K would be 0. You should have a 2, 0. H is positive 2, K is 0. Axis of symmetry would be x equals the number 2. X equals the H number. So x equals number 2. You might want to write that down here as well. You can say axis of symmetry is x equals the H. Vertex, for vertex on number 7, it's going to be positive 1, since it says x minus 1. H is positive 1, K is positive 4, so 1, 4 is your vertex ordered pair. The axis of symmetry is x equals the H number, x equals 1. All right, so that's it. So we should be now ready to go on to graphing these and actually plotting the vertex ordered pair on the coordinate plane, and then doing what we've done before, plotting some points, or you can use that pattern I talked about, the A number pattern, the A number parent pattern, to graph as well. All right, so we're going to first look at just the one that only has an H. It's going to not have a K. So it's kind of more like if we were to graph maybe the 5 and 6. Those ones did not have a K. So we're going to graph that kind of first, and then we'll graph the next time where it has both H and K. So what's it going to do to the graph? As you can see from these 3 parabolas, the different colors, the green, the blue, and the red, all it's doing here, if our blue one here would be our parent function, then it's all going to just move it back and forth, left or right. Red moves right, and the green moves left. So that's what's happening here. It's a translation. So there's going to be horizontal translations to the right or to the left, depending on if your H here is a positive or a negative number. That's why it says here, if H is greater than 0, which means greater than 0 means positive. So if H is positive, then it's going to move to the right. It means when you pull it out, not just looking inside there, but when you pull it out and put it in your ordered pair, and it's a positive number, it's going to move to the right. If its H is less than 0 and it's negative there, then it's going to move to the left. And then we're also going to be able to graph the A here, where we're going to look at the A pattern. We talked about the A pattern before. We'll do that. So the vertex of the graph here is going to be H comma 0, because there is going to be no K on this one. So K would be 0. That's our K there. So the K number is just going to be 0 if we don't see something plus or minus in the back. All right, let's go ahead and try number 9. All right, so for number 9, actually I'll get rid of this here for a sec. We'll come to that in a minute. we have 3 and x plus 2 squared. So we want to figure out, okay, our h number, if we pull this out, h number is going to equal just a negative 2. That's the opposite of what it thinks there. And the k is 0, right? We know the k is 0. So negative 2, 0, I put it over here. This is our vertex, h comma k. We can plot that on our coordinate plane here. So negative 2, this is going to go by 2. So every box is 2, 2, 4, and 6. So negative 2 and 0 is going to be right here. That's where negative 2 is on the x. So at this point we could, I put a couple more numbers down, we can go 1 unit to the right and plug in negative 1 inside here. We can plug it in, do negative 1 plus 2. So we could try that there. We could do it like this. If I did 3 times negative 1 plus 2 squared. And if I take 1 away, it's going to be 1, so it's really going to be 3 times 1 squared. And 1 squared is 1, so that's going to be 3. So negative 1, 3. So negative 1 is right here because we're going by 2's. So negative 1, 3 would put us right about there, in the middle of this box. I could do the same thing for 0. I can put 0 here. That's going to be 3 times 0 plus 2 squared. And that's going to be 3 times 2 squared. 2 squared is 4. So 3 times 4, that's going to give me 12. So 0, 12. So if I'm at 0, 2, 4, 6, 8, 10, 12. 12 puts me right here. Again, that would be your y-intercept. We can't see the y-intercept from the vertex form like we could with the standard form that we did in the last lesson on 8.3. But we can use our axis of symmetry. So if I draw that axis of symmetry down, I'll do it in green. So our axis of symmetry just goes right through this. So kind of a dashed or dotted line there. That's our axis of symmetry line. So if I'm going to be from here 1 unit this way, then I'm going to be 1 unit this way. There's also a mirrored point, symmetrical point. Up here it's 2 units, which is 1 box, so 1 box that way, it's a mirrored point. So it's a very thin kind of graph here. As the number here for A gets larger, your graph's going to get thinner. And so that's what we're going to see. We can go ahead and do that. Now, before I did, we could have talked about the A pattern. Remember we talked about this A number pattern, A number parent pattern. Instead of doing it this way, I could have just thought, okay, well, I'm going to go 1 this way. 1 squared is 1, and then I'm going to multiply that by the A. So 1 times 3 is 3. It goes up 3. There would be. I could go 2 this way. 2 squared is 4. Multiply it by the A number, 3. And 4 times 3 is 12. And that just tells me the same thing as what I'm getting over here. Okay, I'm getting the same thing over here doing it this way. Or I could remember this A number pattern I talked about. And this is my own kind of thing that I just figured out. That it just seems like it makes sense. You could just do that pattern to get some points here. So let's come down and draw this, a little U shape. So it should be, it's a thin U, but it should be not a V. Trying to make it not a V there. And then put your arrows on the ends. And that's what it should look like there. So this one I put over here opens, and we should have maybe looked at that first possibly. We didn't obviously need to, but we could have saw that, well, because of this A number is a positive number, that is positive for A, then it's going to open up. Opens up, which means your vertex is down below. We talked about minimum and maximum. This would be a minimum value for your vertex down here at 0. So if I needed to know what the minimum was, again from yesterday, minimum would be 0 on this one. All right, let's move on to our next one. Before we go there, let's do our joke of the day. So what do you call 2 monkeys that share an Amazon account? What do you call 2 monkeys that share an Amazon account? Well, you call them primates. Primates. Oh, that's good. Primates, obviously, monkeys are called primates, and prime mates. I like that one. Okay, here we go with, we're just going to add, the only difference here is now we're adding in the k. So what k is going to do is it's going to shift it now, moving up or down. So we have the h is already going to move it to the left or to the right. So you can see this one is moving right, and then the k will move it up. So it's h moves it left to right, the k moves it up and down. So it's going to be, again, translation, in this case vertically, either up or down. That's what the k does. So that's all we need to know for this, and we'll move on to looking at number 10 on page 264. And we can maybe do this first. Which way does this open? Well, since our 1/4, our a number is negative, so a is negative. That means it's going to be opening down. So I know right now this is going to open down. My arrows are going to be pointing down. And actually, I forgot, I missed coming back. Let's go back to number 9. I'm sorry, before I get ahead of myself there. Compare the graph of the function to the parent function. This is our parent function, just the regular, most basic x squared. This is what we would say here. I had it up there, but I took it off. We would say that the graph of m is a horizontal translation 2 units left and a vertical stretch by a factor of 3 of the graph of the parent function of the the graph of f. So you need to write that down, and you can just kind of maybe abbreviate. You could say horizontal translation 2 units left and vertical stretch by a factor of 3. That's really the two things that's different from the parent function to this function. So your a number, like I said, it's thin, it's narrow. It's narrower than the parent function. So when it's narrower, it's going to be stretching, vertical stretch by the factor of 3. That's the a number. And then horizontal translation 2 units, that's our h number. But since it's negative, it's going to go left. So you need to make sure direction, the number, and the direction for translation. So make sure you get that part down. Again, mainly that you say right there, horizontal translation. These two things here, those are the two main things to write down for the transformation. How is it different? That's when we talks about comparing. You're talking about a transformation. And so you need to use the words of transformations, which is translations, reflections, stretching, or shrinking. So those are our words that we would use. All right, now coming over here, you know this opens down. So what's our vertex? H right here is going to be the opposite of what we see. It looks like -6, but H is a 6. So 6 for the x-coordinate. The K is 4. So 4 right here, H comma K. So 6 comma 4 would be our vertex. We can go ahead and plot that point. So again, we're going by 2's. There are 2 everywhere on the y-axis, 2 on the x-axis, 2, 4, 6. And then up 4, 2, 4. Right there is our vertex. And we know it's going to open down from there. That's why I did the coordinate plane that way. Alright, so now what I could do is I could do it where we plug in numbers. I can plug in 4 to this and do 4 minus 6. That would give me a -2 squared, times it by the -1/4, and so on. But we could just do our A pattern. Let's talk about our A pattern. Our A pattern, if I did go back 2 units, and I might want to go by 2's, or I could go by 4's. Because this is a 1/4, I'm going to have to multiply it by 1/4. The fact that it's negative means I'm going to go down in this direction, so I want to multiply by the 1/4. So let's say if I use my A number pattern, parent pattern, what I would do is I'm going to start by 4. If I go 4 units each way, okay, 4 units each way, I got to multiply that by the A number. This is our A number, is the 1/4. So that will equal 1. It's actually a -1/4, so it's going to go down 1, -1. So I go 4 units this way, I'm going to go down 1. 1 is half a box. I could go 8 units, 2, 4, 6, 8 units. So I do 8 units. I'm going to multiply it by my A number, the -1/4. And I can cross cancel here. That's a 1 and this will be a 2. So this is going to be -2. I'm going to go down 2. So 2, 4, 6, 8. I'm going to go down 2, which is 1 box. So it's kind of like that. Now it almost looks like we're going to go straight like a V, but we're not. We're actually going to curve this. If I did just go 2, if I put 2 in here, 2 times 1/4 is a half. So half would be putting me kind of like right in here. If I do 6, it's going to be putting me -2. So it's a bit wide, as you can see. So I go this way 2, we're going to go down about a half. This way 4, we're going to go down 1. 1, 2, 3, so actually go 2, 4, 6, 8. We're going to go down all the way down to here. And then we can kind of draw this. So it's a kind of a very big, almost looks like a dish, like a satellite dish almost. Very wide. Put the arrows on the ends. Arrows on the ends. So very wide right there. We can fill this in. We know when we're at 4 right here, we were going to be right there. That was going to be, you know, maybe the half down. So this would be 3, 3.5. So 3.5 would be there. If we're at 2, we're going to be at 3 exactly. And we could see how that would work. If we plug that in, that's the numbers we would get. That's going one direction, but axis of symmetry, maybe let's draw that axis of symmetry down just so we can see it. Axis of symmetry makes it symmetrical all the way down. This is our green axis of symmetry. It's not a part of the graph, it's just kind of the right down the middle. It's an axis of symmetry. And the last part is just how do we compare this to its parent function, the original. So what's different? Well, we did do these transformations or translations here. We moved 6 units to the right, we moved 4 units up. So we're going to say that. We're also going to be reflecting this. It's now opening down, so it's going to be a reflection in the x-axis. And this 1/4, since it's smaller than 1, we're going to be talking about a shrink on this one. So here's our things. It says vertical shrink by the factor of 1/4. We got to say that. Reflection in the x-axis. We got to say that. And then translation 6 units right and 4 units up. So those 2 translations. So really 4 things were different on this one that we have to say and state on how to compare this back to its parent function. How did this change? How is this different from the parent one? I'll leave that there for just a second. And we just have 2 more problems. All right, you can pause it if you need to keep looking at that. Number 11 and 12. For 11 and 12, it says to graph G. Well, G of x says there's an f of x function there in vertex form. G of x just says f of x plus 2. So you're not graphing necessarily this. What we're graphing is if we were to plug in x plus 2 into this function for x, it's going to change that function a little bit. So this is what we have to plug in. So we're going to enter, we're going to input or substitute x plus 2 for x right there. So let's do that and find out what function we would get then for our g of x, because we're trying to graph the g of x. So g of x down here is now going to be the 3 times, instead of x, we're going to put x plus 2 then it's going to be plus 1 squared minus 1. So the only thing to do is just combine the like terms there of 2 plus 1. That makes it 3. So we're going to say g of x is equal to 3, and then it's going to be x plus 3 squared minus 1. So now when we graph this, our vertex, we can talk about our vertex first. Vertex would be the ordered pair, -3, -1. And so that's going to be, if we go by ones, -3, 1, 2, 3, and then -1 will put us down to here. So that's if we go by ones. And then we can use the parent pattern. We can say we can go 1 unit, and then 1 times 3 will be going up 3. 1, 2, 3. Got to multiply it by 3 because 3 is right here our A number. So A number here would be 3. So let's take a look at that graph. And this is going by ones. It's going by ones up this way as well. So 1, 2, 3, -3, -1. There's our vertex. So I'll highlight. Oops. So right here is our vertex. And if I do that A pattern, 1 times 3 is going to tell me to go up 3. 1, 2, 3. So there's that number. Axis of symmetry is here. It's 1 away from this way. 1 this way would put it also there. We can go 2, and then 2 squared would be 4. 4 times 3 would be 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So since 12 is going to be up here, it's not going to get to this line until up here. So that's why you can see it's right about a little bit shy of that. So same thing over on this way. So 1, a little bit less than 2 on this direction as well at the top. And that's it. Number 12, on this one, what do we have to do? So for this one, here's our f of x function. The g of x says negative f of x. So this is the only thing that we have to do is we have to multiply the entire function by a negative. That's what we got to do. Multiply the function by a negative sign. So basically I could put parentheses even around the whole function here and say I'm going to multiply it by negative. So negative times this whole first part. This whole first part is like one term here because it's 1/2 times a parenthesis. So when we write down, what is our g of x on this one? G of x is equal to negative times the half will be a negative 1/2. And then x minus 3. Notice that minus 3 doesn't change because the negative is in front of the 1/2 squared. But then we multiply. Here's a second term. So there's only 2 terms. So this is all one term. That's the second term. So you're distributing the negative to this, which the 1/2 takes the negative. Negative goes to the -5 here. It makes it a positive 5. So that's what we have to graph now. So our vertex on this one, identify our vertex first, is going to be the h is positive 3 and k is positive 5. It is going to be opening down. So 3, 1, 2, 3, and then 1, 2, 3, 4, 5. If it's going by ones, we're putting it right here. And then it's going to open down from there. Again, we can go 1 this way, and then 1 squared is 1, times it by 1/2, it's going to go just down a 1/2 box. 2 this way, 2 squared is 4, and then 1/2 of 4 is going to go 2, when you go down 2 boxes there. So that's kind of how we're going to see this. Let's go and take a look at it. So there it is. So let me highlight a couple points here. So our vertex again would be 3. So there's 2, 3, then up 5. 1, 2, 3, 4, 5. Here's our vertex right here. And then because A is a negative 1/2, that's what we would multiply by. So we go 1 this way or that way. we're going to be multiplying 1 squared, which is 1, times a half. Negative half puts it down halfway right there and right there. If we go 2 each way there, 2 squared is 4. 4 times a half is going to be 2, so it's going to go down 2. So 2 this way, we go down 2, puts me there. 2 this way, I go down 2, puts me there. And you can kind of keep going. If we want to go 3 all the way over to the y-axis, that's going to be 9 times a half. It's going to be going down, half of 9 is 4 and a half. So 1, 2, 3, 4, and then halfway would put us right there. So I go 3 this way, down 1, 2, 3, 4, and then half again, puts us right there. You can see how that A pattern just continues to work as you go each number from that vertex back and forth. Alright, so that concludes our 8.4 lesson, and I'll see you guys on 8.5. Have a good rest of your day.